Good evening, friends. So, welcome back to our class on parametric differentiation. So far, we have learned differentiation of various functions, like direct functions, which we called as explicit functions, and functions which are implicit functions. And now, today, we are going to focus on parametric functions. So, this kind of differentiation, to understand clearly, let us go to the whiteboard and understand from there itself. Let us go to the whiteboard. Yeah. See, now in the case of functions where there is a direct relation like this, y is equal to x or y is equal to x square. This we know very well, these are explicit functions. Here there is no confusion at all because we are able to straight away understand that there is a direct link here. Some implicit functions also we learned where y plus sine y is equal to x plus 2y. In this case, we have to rearrange y one side and x other side and then differentiate. This type of functions we called as implicit. This also we have learned. Now we are going to see a third kind called as parametric. Parametric differentiation. This is third category in this. Let us see how to understand this. In this case of parametric differentiation, both dependent and independent. Y is dependent and x is independent. I think you are aware of this. Both y and x, they are linked to third variable. They are linked to a third variable. That means what? That means let us say, let us take one example. Let us say we are having distance and velocity, displacement and velocity of a some projected car or something. Let us say we call it as now rocket. Better example is rocket. Then what will happen is displacement means distance traveled. With respect to time, displacement and velocity both will be changing. So if t is time involved, what will happen here? Displacement will vary because as the projectile moves upward, with respect to time, the distance keeps on increasing. As the rocket goes up, distance will be increasing. This is one. Another one, since displacement is changing with respect to time, velocity is also changing. So if you consider displacement or velocity depending on the displacement, then v is depending on time, displacement is also depending on time. Displacement will vary, velocity will vary. Velocity also will vary with respect to time. Okay. So that means what? If you write t here, t will be having displacement. Generally, we represent s for the displacement, and then we can call here velocity. Both are having link. So you can relate s and v through the parametric differentiation. That is the idea here. So if you want, let us say there is a function called x is equal to at square. Y is equal to 2at. Let us say there are two functions. X is connected to t, y is also connected to t. Then with respect to t, both the functions will differentiate. Dx by dt is equal to 2at, like power differentiation. So your differentiating now t square with respect to time. So 2a t square, 2a t to the power of 2 minus 1. This will become 2a t. Now in the case of y with respect to time, dy by dt is equal to 2a because t differentiation is 1. Now I want to find out dy by dx. Ultimately aim is what? Dy by dx. So now you know dx by dt, you know dy by dt. If you divide dy by dt with dx by dt, dy by dt divided by dx by dt, what you will get? Dy by dt, this divided by sign, can you convert it like this? And take the reciprocal, then dt and dt you get cancelled, dy by dx will come. So what is the substitution here now? Dy by dt is nothing but 2a divided by dx by dt. It is called 2at. So 2a 2a get cancelled. You will get 1 by t. So dy by dx finally we got as 1 over t. So what is that we have done here? We have seen both the functions and then independently we differentiated them with respect to the parameter what they gave here. What is the parameter? T is called as a parameter. This is also called third variable. It is also called as third variable. So right now, because we are calling y and we are calling x, both will be connected to third variables, either t or sometimes they are connected to angle theta. So we should know exactly to what third variable they are connecting. And then if they are connected to t, dx by dt, dy by dt. If they are connected to, let us say, theta, then dx by d theta, dy by d theta, you find out, divide them. Then you will get the dy by dx. So this is only called parametric differentiation. In parametric differentiation, you have a link between between for each independent and dependent variables with a third variable. There is a relation. So we have to differentiate individually and then divide them. By solving one or two sums, we'll understand this now. Let us go to the sums. First one, x is equal to a cos theta and y is equal to a sin theta. So this is a sum. We have to find out what? Find dy by dx. What we do now? Take x is equal to a cos theta. Differentiate with respect to theta now, because here parameter is theta now. Previously, example when we are discussing previous page, we saw t, now it is theta. So minus a sin theta, cos theta differentiation minus sin theta, so minus goes over here. In the case of y is equal to a sin theta, dy by d theta will become a cos theta. So now divide both to get the dy by dx. If you want dy by dx, what I should do? Dy by d theta divided by dx by d theta. So what is dy by d theta? A cos theta divided by minus a sin theta. Cancel a and a, plus by minus minus cot theta. This is our first sum. So next sum, let us see. X is equal to a t square, y is equal to 2at. Very simple. Dx by dt first you find out, it is 2at. Then find out dy by dt, that is nothing but 2a, and divide. Dy by dt divided by dx by dt. So that becomes now 2a divided by 2at. So you are having now 1 over t. Understood now? Next, third sum, let us say. X is equal to a, open the bracket, theta plus sine theta. Y is equal to a into 1 minus cos theta. So first, x is equal to, you take theta plus sine theta. So dx by d theta we have to do. Theta differentiation is 1. Sin theta differentiation cos theta. Why theta differentiation is 1? Because here you are differentiating theta with respect to theta. That is why it is 1. Here you are differentiating sin theta with respect to theta. So sin theta differentiation is cos theta. That is the way. That is the thing here. So here y is equal to a into 1 minus cos theta. So again differentiation of y with respect to theta. One differentiation is 0 minus cos theta differentiation minus sin theta. So a open the bracket, 0 ignore, minus into minus plus sin theta. So this is nothing but a sin theta. So now I wanted dy by dx. A sin theta divided by a into 1 plus cos theta, dy by d theta divided by dx by d theta. If you remember your basic trigonometry, sin theta can be written as in half angle formulas like this. 1 plus cos theta also under half angle formulas, 2 cos square theta by 2. You have to go to trigonometry and remember these formulas. 2 into cancelled, cos theta by 2 will go one time. So you are left with now sin theta by 2 divided by cos theta by 2, which is nothing but tan theta by 2. So this is very important sum. Always remember dy by dx when we are asked to find out, we should only leave the answer in the parametric parameter. Here theta, we should not again convert back into x. Differentiate x to the power of 2 by 3. What is the sum that time? We have to write down. Yeah, x to the power 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 3. Find dy by dx. So here what we do, we put substitution. Put x is equal to a cos cube theta and y is equal to a sin cube theta. So if you substitute like this, what will happen? Dx by d theta, you do it. It will become 3a cos square theta, because cos cube theta differentiation 3 cos square theta, that 3 I put it before cos theta differentiation minus sin theta. Here dy by d theta, that will become 3a sin square theta, sin theta differentiation cos theta. Okay. Now dy by dx. Division of these two, 3a sin square theta cos theta divided by minus sin 3a cos square theta sin theta. Sin theta will go here one time, cos theta will go here one time, 3a and 3a will get cancelled. You are left with minus of sin theta by cos theta. It is nothing but minus tan theta. Nothing but minus tan theta. Now here, if you want to know what is this tan theta value, you can convert it into back x. So how do we do? We know x is equal to a cos cube theta, and we have to substituted y is equal to a sin cube theta. Then what we do now, divide y by x. A sin cube theta by a cos cube theta. A and a get cancelled. This will become tan cube theta. So y by x is equal to tan cube theta. Therefore, theta is equal to cube root of y by x. So here, this substitution, here in the place of minus tan theta we are having here. So this is called tan theta. Yeah. Cube root of y by x you can write down. Okay. This is the answer with a minus sign, remember. Next sum we will do. That is very simple sum. I think this we have done already. x is equal to 2 sine theta, y is equal to 2 sine square theta. So both we will try to find out the differentiation. This will become 2 as it is. 2 sine square theta becomes 2 sine theta. Sine theta becomes differentiation cos theta. So this is nothing but 4. Okay. So therefore dy by dx is equal to okay friends. So I have done almost important fundamental sums, but another one big sum is there, which is examination point of view, very important. That sum I will do in the next video class. With that, we'll conclude the parametric differentiation. Thank you.